Good morning. This is your stats sensei, Mr. Spensei, and we're going to break down the scenario 3 in the note spiral. This has been modified slightly. So, a credit card company with more than 3,500 card holders wonders whether giving frequent flyer miles for every purchase would increase card uses, which has a current mean of 2,500. So, that right there is probably my population mean. So, mean is 2,500, probably. The company gave a free mile to a simple random of 36 card holders. So my sample size is 36. And found the sample mean to be 2542. So X bar is 2,542. And the standard deviation is assumed to be 109. All right, I'm going to go ahead and do this one on our template. And because I think that'll help you understand, make sure that we understand how to use that template correctly. I need to grab one. All right, so our template. The very first thing it says is write the hypothesis. Well, that's also the first thing we need to do on our recipe card. Our recipe says that. So the null hypothesis, HO will always be mu equals HA will be mu as well. So we're always going to be working with a mu equals if we're talking about the mean. So in this case, the population mean is 2,500. Make sure we're using that as opposed to the sample mean, which is 2,542. So the population mean of 2,500, that's where the status quo is. And they wanted to know whether it would increase. So this needs to be a greater than 2,500. Just as a reminder, these two numbers will always be exactly the same for our class. Parameter. Our parameter is let mu equal the true population mean amount. What did we care about? We cared about credit card usage. So credit card use. With frequent flyer miles. Because we want to know after they gave out the frequent flyer miles, whether that helped. Okay, so that takes care of that. The next thing we need to do is our conditions. Well, the very first condition we need to check is random sample, and we need to determine, did they run a random sample? Well, it says a simple random sample of 36. So conditions, random sample of 36, and that was given to us. The next thing we need to check is the N is less than 10%. So in this case, N is 36. 36 times 10 is 360. And that happens to be less than the 35,000. We always have to make the comparison to the population. So that satisfied. The N is less than 10%. The next thing we need to do is to check for normality. Well, they didn't tell us the shape of the distribution. It could have been skewed. It could have been normal. We don't know. But our sample size is 36, which is greater than 30. So it's normal. The distribution of the means is normal by CLT. All right. Now, some classes is going to be really important to write that is approximately normal, because that's technically what it is. Approximately normal by central limit theorem. So our formula is Z equals X bar minus mu standard deviation divided by the square root of N. We need, next thing it asks us to do is to go ahead and draw the look of our distribution. Well, what do we have? Well, we know the distribution of the means is centered on the population mean, and the population mean is 2,500, or at least that's what the claim is. But we got an X bar of 2,542, and we're looking for it to go this way. So we're going to go ahead and write down what our plugins are. So our mean was 2,500. The standard deviation, they told us, was 109. The X bar is 2,542, and our sample size was 36. And when we look at our graph, it's like very obvious that we shaded to the right. Okay, the next thing we need to look at is our plug value. So I'm going to plug into this formula. So I want the probability that Z is greater than 2542, that's my X bar, minus my population mean of 2,500, divided by 109 over the square root of 36. So let's go ahead and run that. Stat test, Z-test, which happens to be the very first thing. Press enter. And our mean, population mean was 2,500. Our standard deviation was 109. Our X bar was 2,542. And our sample size was 36, and we shaded a greater than. And I get a Z-score of 2.3119. So the probability that Z is greater than 2.311 is what we're looking for. And that probability is our p-value, and our p-value is 0.0103. So 0.0103. So they didn't give us an alpha this time to make a comparison. So if they don't give us an alpha, we're going to use 0.05. Well, 0.0103, make them the same length. Well, 103 is definitely less than 500. So whenever the p-value is less than alpha, we reject the null. So now we need to write our conclusion. And our conclusion is going to refer back to our definition of the parameter. But we start off with our p-value is, well, what is it? 0.0103. What's our decision? We reject the null. That pen is dying. There is sufficient. That just means we have enough or plenty of evidence to suggest. We didn't really prove, but it sure appears this way, that, and now we're going to restate our parameters. Well, what was our parameters? The true population mean amount of credit card usage with frequent flyer miles. Population mean credit card use with frequent flyer miles is, well, what was our our alternative hypothesis? Where our alternative was greater than 2,500. So we needed to say, hey, is greater than $2,500. All right. So based on this, if we had to explain in a layman's terms, we say, hey, we took a sample of 36 out of the 2,500, out of the huge number that have the credit card. And it certainly appears, based on our study, we got a sample mean of 2,542, and that indicates that the credit card usage went up. So we believe the credit card usage went up and the frequent flyer miles helped. All right, thanks for watching. Hope to see you on the next one.